So here's another question from an AQA Paper 1. It's another trace table. This time we're using an array. So it's saying here that we've got a bitmap image and it's using shades of grey, which equate to a number in an array. So in this case here we've got black, which is apparently equating to 0. We've got a white that's equating to 99 and something that's not quite white, etc. And these all equate to the different numbers that are in this array, and this array is called row. So it's repeated here in the algorithm: 56, 34, 0, 99, 72, 23. So remember that arrays are indexed. So these have got an indexed position. So 0, 1, 2, 3, 4, 5. So each of these values corresponds to the array row at position 0 or at position 1, etc. So here we go. We've got a new row, which is going to be a new array, or a new list, if you want to call it that, if you're doing Python. So it's an array called new row, and we've got that here on our trace table up here. So it's got all the different positions for new row: 0, 1, 2, 3, 4, 5 for us. They're all starting at value 0, and that's the case because that's here. And then we've got a variable I. So sometimes we use I when we're doing a for loop for counting. So for I in the range, you can use count as well, but I stands for increment. It's kind of an old programmer thing. So I starts at 0 and we start off. So I is 0. If row at I, or row at I is 56, is greater than 50, well it is, then new row at I gets 99. So 99 we're going to write in there because that's new row at 0 and 0 I. So end if, end for, we're going to go back up here to this for, and I gets incremented. So I was 0 and now it's 1. So if row at I, so row at 1, which is 34, so if 34 is greater than 50, well it isn't, so we're not going to write anything in there, and we're going to go end for, and we're going to increment I. So we already incremented I there first time to make it 1, so we're now incrementing it again to make it 2. So I is now 2. So if the row at I is greater than 50, well I is 0 there, so it's not greater than 50. So again, we don't do anything there, and we just go to end for and we increment, so I becomes 3. So if row at I, which is 99, is more than 50, well it is, then we put new row at I 99. So we're I is 3, so new row here 99. Write 99 in there. End 4, come back up, increment, I becomes 4. So again, if row at I, which is now 4, 72, so if 72 is more than 50, it is. Don't forget to increment I. 99 is going in there. Then we finish, we increment again, so we're up to 5. That's the last time now. So if row at I, which is 23, if 23 is more than 50, then new row at I, but it isn't, so we're not going to do anything there, but we are going to increment I up to 5 like that. So we've now got a new row, which is 99, 0, 0, 99, 99, 0. And if we go back and check that, then it should only do that when it's more than 50. So position 0 was more than 50, position 3 was more than 50, and position 4 was more than 50. So 0, 3, and 4 are now 99. So we did the trace table. So the last part of that question was state the purpose of the algorithm. You could say all sorts of things maybe, but I think the purpose of this algorithm is probably to make an image that was several shades of grey into a black and white image. So we've now made this black and white, because if we look, 0 was completely black and 99 was completely white. So we've now only got noughts and 99s in the row, because the row looks like this: 99, 0, 0, 99, 99, 0. And so that would be white, black, black, white, white, black. So we've gone and made the image a black and white image. So that's the purpose of this particular algorithm. So again, just a fairly straightforward trace table, but this time obviously using an array. So we need to know these index positions of the array if we're going to be able to do that one correctly.